The end behavior of a function has to do with what the function is doing as you go off towards infinity in either direction. So basically, as x gets bigger and bigger and bigger, and we sometimes say as it goes to infinity or as x goes to negative infinity, what does the function do? And this can be done really easily oftentimes with a graph. Sometimes you just have to do it with what you know about a function. So let's talk about a couple of simple functions and a couple of families of functions and how you would know what is happening with its end behavior. So for instance, if you had a linear function, it could be written as a standard form, it could be written as in slope intercept or point slope, but you had a linear function. So we could say, well, maybe something like this. And you'd say, well, as I continue out this way, as x's just keep growing and growing and growing, what does the function do? The answer is, well, it will also just continue growing and growing and growing, in this case, towards infinity. But end behavior isn't just as x gets larger and larger in positive numbers, it's also as x gets larger and larger negative values. So in that case, you'd say, well, this linear function would continue down towards negative infinity. It would just keep getting more and more negative. Now, of course, if you made the line negative, if you did a negative slope and you did this, well, that would then reverse what those end behaviors were. You'd say, okay, as the x's get larger and larger positive numbers, the line would continue down towards a negative infinity. And on the other hand, for this negative slope line, as the x's became more and more negative, larger and larger negative numbers, this would continue up and go to positive infinity. So linear, it just really has to do with what the slope of the line is, if it's positive or negative, which is going to give us that direction. Now, other polynomials, higher ordered things, like an x squared or an x cubed, they also have an end behavior, and you would look at that end behavior based on really whether the power was even or odd. All even functions, x squared, have an end behavior that is the same in either direction. So for example, I drew an x squared graph here. This isn't x squared. I just sketched a parabola. But as you plugged in larger and larger and larger x's, the y's will just keep getting larger and larger and larger towards infinity. And if you plugged in more and more negative x values because of the squaring, they will get big positive outputs. So in both cases, the end behavior here is it's going up to infinity in both directions. Whereas an odd powered function like x cubed, plugging in large positive values will just get us bigger and bigger positive values as our end behavior. But plugging in negative values gives us larger and larger negative values. So the end behavior is different depending on the even or oddness of the function, of the power. Now, exponential functions are a little bit different. So here I've drawn the exponential function 3 to the x, or at least a reasonable sketch of it. If I plug in bigger and bigger values of x, this will just continue to grow larger and larger and larger. But if I were to plug in more and more negative values, it just keeps getting closer and closer to 0. 3 to the negative 100, 3 to the negative 1000. It will never become negative. It will never cross this axis. So the end behavior here is as x goes to the positive infinity, the outputs also go to positive infinity. But as x goes to negative infinity, the outputs approach 0. So the end behavior here, 0 on the negative direction, infinity on the positive direction. Now a logarithmic function, on the other hand, I've drawn natural log here, a sketch of it, looks like this. And as x's get bigger and bigger and bigger, this will continue to grow. It really kind of bends down. We call this concave down, but it will continue to grow. So it's still growing to infinity. It's just getting slower and slower and slower at doing it. But here, we don't have the ability to go to negative infinity. There is no end behavior over there because we can't take the log of negative numbers. So instead, the end behavior here is really just as we go to 0, x gets closer and closer to 0, the function will just keep going down, down, down towards negative infinity. So again, there are some good things to know here about what a function looks like, and just kind of have these families of functions in your mind. But the biggest thing is, if you look at a graph, end behavior just has to do with, as I go out in this direction, what is the function doing? Is it getting bigger and bigger, bigger? Is it getting smaller, smaller, and smaller? Is it leveling out towards something? What happens? And then once you've figured out what happens when it goes to the positive direction, then turn around and say, well, what if it went to the negative direction? Again, does it keep getting bigger and bigger and bigger? Does it get smaller, smaller, and smaller? Or, like that exponential, does it level out? So make sure and check both directions. And this is how you describe a function's end behavior. If this video helped you, please like and subscribe for more math help.